we'll look at logarithm graphs. And in part A, we're going to sketch a graph of f of x equals log base 3 of x, and we're going to find the domain. So I'll show you in the calculator how to do this. Remember that, first of all, we need to convert log base 3 into a log base 10 or a natural log. So if you just use the change of base formula, we could say log x over log 3. So that's our function. So if we go to our calculator, we're going to do log x in the parentheses, that's very important, and then divided by log 3. And what we know should happen here is that with a logarithm, there's no transformations or anything going on. This is just a base 3 logarithm. So we should have the y-axis as a vertical asymptote, and it should be a inverse of an exponential. So if I graph it, okay, there's the graph of it. So we're going to sketch that graph. So on our axes, so it looks something like this. So vertical asymptote at the y-axis. And we can graph the other ones very similarly. We need to find the domain here first. Remember, with a logarithm, no matter what the base is, whatever you take the log of, so this part right here, whatever's there needs to be greater than 0. So we set x greater than 0. There's no solving to do there. That's your domain. So we can say domain, the domain is 0 to infinity. With the next one, we notice that we already have a base 10 logarithm because there's no base written there. So it's assumed it's a base 10. So we go right to our calculator and enter log parentheses x minus 3. So if we graph that, what should happen here is that x minus 3 has to be greater than 0. So we should get a vertical asymptote at 3. So again, it's hard to see here what's happening because your calculator just can't draw it going down toward x equals 3. But this is where we outsmart the calculator. And if we draw that on our screen, or from our screen, x equals 3 is our vertical asymptote, and then we just draw it like that. Okay, and the domain, to find that, you set whatever you're taking the log of, in this case x minus 3, has to be greater than 0, so add 3 to each side. So the domain is x is greater than 3, or you can say parentheses 3 infinity. So we can graph each of these others in a similar manner. You'll have to do the change of base for part C. In part D, that's a natural log, which we have a calculator button for, natural log. Make sure you put parentheses around the numerator and denominator there, so that one could be a little bit tricky. I'll actually put that one on the calculator, but you can try the rest of these to graph them. And then at the very bottom, finding the domain of those functions. Again, you're setting whatever you're taking the log of, in this case 3x minus 5, has to be greater than 0. Over here, x minus 1 divided by x has to be greater than 0. So that is a rational inequality, which goes back to previous chapters' work. So that's where you find the undefined values and the x-intercepts, and then do your sign chart. So I'll put the answer up to that. So pause the video and try these. In part C, notice that we have a logarithm graph shift it to the left 5. So that plus 5 shifts it to the left 5. So our vertical asymptote is at x equals negative 5. So when you put that in your calculator, log of x plus 5 in parentheses, and then divided by log 2. Part D, this is the little trickier one to put in your calculator. So in your calculator, if you do natural log, the parentheses pop up, and then put the x plus 4 in parentheses itself, because we have a fraction here, and then divide it by parentheses around x minus 2, and then end the parentheses for the entire logarithm. So then when we graph that, I graphed it thicker so we could see it good. So it looks something like that. Now remember that at negative 4 and positive 2 is where we're going to have some issues going on. As far as the domain goes, if we set our rational function greater than 0, so x plus 4 over x minus 2, that has to be greater than 0 because we're doing the natural log of that. So when we do our sign chart, anything to the left of negative 4 is positive, and anything to the right of positive 2 is also positive. So that means our domain is what I have written here, and that's why there's nothing between negative 4 and 2, because any x value between negative 4 and positive 2 will give you a negative answer in here, and you're going to try to take the natural log of a negative number. You can't do it. That's undefined. And then in the last few, finding the domain. Part A is pretty straightforward. You just set 3x minus 5 greater than 0. So notice for these logarithm domains, you're setting whatever is that you're taking the log of, you're setting that greater than 0. Part B is similar to Part D above, in that you have a rational inequality. Make your little number chart using x equals 1 and x equals 0 as the numbers where you have zeros or vertical asymptotes. And we notice anything to the left of 0 or to the right of positive 1 will give you positive answers. So that's your domain.